Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the count and say problem. The count and say sequence is a sequence of digit strings defined by the recursive formula count and say 1 is the string 1 and count and say n is the way you would say the digit string from count and say n minus 1, which is then converted into a different digit string. To determine how you say a digit string, split it into the minimal number of substrings such that each substring contains exactly one unique digit. Then, for each substring, say the number of digits, then say the digit. Finally, concatenate every said digit. For example, the saying and conversion for digit string 33222251 is 2 3s, 3 2s, 1 5 1 1. Hence we end up with 2 3 3 2 1 5 1 1. Given a positive integer n, return the nth term of the count and say sequence. So here we're going to do n equals 1. That gives me output 1. I'll let the ambulance go whizzing past my window. For n equals 4, we're going to start with 1 and we're going to say that it's 1 1. And then 1 1 is going to be pronounced as 2 1s, and 2 1 is going to be pronounced as 1 2 1 1. So the answer is 1 2 1 1. This is actually a neat little problem because one, it's recursive. What we need to do, is basically do num to say is equal to count and say n minus 1 and then return something. Now the neat thing about this problem is that this is actually just a fancy way of getting you to do a run-length encoding. We want to turn this into its run-length encoding, which is 2 3s, 3 2s, 1 5 and 1 1. And then just concatenate all of those. So what I want to do is I want to do a join on the stir I plus stir j for ij in run length encoding of num to say. Let's take that into self.runLengthEncoding, and let's just stick a line break in there so it doesn't get overly long. And so then we need to do def run length encoding self n. How does the run length encoding work? Well, basically what it's going to do is it's going to take a string and it's going to start going through it letter by letter. In fact, I'm fairly sure there's something in the Python standard library which does this, but we'll do it by hand just because we've eliminated half the problem if we use the standard library. So car is none for letter in, actually let's call this S. If car is none, in fact we're going to count to 0. Car equals s, count plus equals 1. Elif, sorry, not s, letter. Elif letter does not equal current. Result.append the count with the current thing that we're tracing. The current thing is going to become letter, and the count gets set to 1. Else, the count gets incremented. In fact, if current is none, no, that's fine. We don't even need to make the plus equals 1. The only case can be when that's a 0, so we can just set it equal to 1. That's fine. It's one slightly less chance of a bug. once we get to the end of the for loop, we actually need to make sure we do a result.append count current return result. So let's quickly run through this and show this is a run length encoding. So the current is none, the count is 0, and the result is an empty list. In fact, you know what I'm going to do? I am going to remove a boundary condition. I don't want to worry about this case. The string will never be empty, because here, if n is equal to 1, return 1. So our string will always have some number of elements in it. So we take the first thing, we set that to be the first thing we're focusing on, and its count is 1 because we've seen it once. And then for every other letter, so we've stored the current thing is 3, the count is 1. The next letter is the same as the current thing, so we're going to increment the count. So the count is now 2. We're now looking at the 2. This is different. The letter 2 does not equal the letter 3. So we're going to put our 2, 3 pair in the result. And then we're going to set the current thing to be 2 and say we've seen one of them. That will repeat. We've now seen 2 of them. That will repeat. We've now seen 3 of them. 5 does not look like a 2. So we're going to put the 3 2s into our result. And then we're going to set the current to be 5 with count 1. 1 does not look like 5. So we're going to put the 1, 5 into our result. And then we're out of the loop. So then this is where we need to say, well, I also saw 1, 1 at the end there. And we are done. Return the result. Back up here, that's our run length encoding. It gives us the count letter pairs. So we're going to take the count plus the letter, in which case is a number. So it's 3 3s. We're going to join those together. Sorry, 2 3s. It's 2 3s, so we're going to join those together like that. And then it's going to be 3 2s. We're going to join them together, and so on and so forth. And then just concatenate them all at the end. We've handled the base case, which I initially forgot. It was a bit naughty. It's recursive without a base case, and now it is recursive with a base case. We also need to use the self. I think that'll do it. Let's test this thing. First, a bit of a typo check. I've almost certainly made a typo somewhere. No, it worked. Use all the example test cases. Let's see if it works for our case 4. Looks promising. Python's not very good at recursion, but we do know n is going to be small, so it's fine. This isn't a branching recursion, it's just a linear recursion, so this should all be absolutely fine inside Python. Nice. Thank you for delayed pop-up. So, a nice little problem. Basically, it's a run length encoding problem and a little bit of recursion, although the recursion was fairly explicitly stated, so you just kind of had to copy that. And run length encoding is one of those algorithms that you don't use often, but it's good to have in your tool belt. So that is it from me for today. I do apologize for being a wee bit late. Work ran quite a bit over time, but hope you don't mind. And do remember to do all those good things like, comment, subscribe. Do let me know what else you want to see on the channel. Let me know what you're enjoying on the channel, and I'll try and make more of that content. Anyway, that's it from me for today. Hope you have a good evening, and I will see you next time. Bye.